All right. Well, this is going to be probably review for some of you, but I tried to, keep a pretty good balance here of just general high-level stuff, and then diving into a few things. It's also got a mixture of some of my slides from a systems troubleshooting presentation that I gave a while back. So let's just go ahead and get started here. So why is it important? Why is IT in broadcast important? Well, hopefully most of you understand these, why IT is important to broadcast. We're no longer just broadcast engineers. We have become IT personnel. Like it or not, some of us kicking and screaming. I'm kind of native to that world since I had, kind of started my career in the mid to late 90s and watched the whole progression. But I know that's not always the case for some people who've been in this for many, 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 many years, longer than I have. So in addition to servers and desktops, most modern broadcast equipment has an Ethernet port and an IP address. The world now revolves around IT. I mean, it seems like just about anything now has an IP address, which is why we're moving to things like IPv6 eventually. So even simple things like thermostats have been connected. You look at the phenomenon of IoT, or Internet of Things. I mean, think about how many devices you have around your home. They're connected to the internet somehow. I mean, in my little house alone, it's just me and my wife, and looking at our router, we have easily 40 different devices connected to our network. It adds up in a hurry. So what do we support as broadcast engineers? Well, there's the traditional stuff. We've got desktop computing, file servers, network switches and firewalls, the telecom stuff, and in some facilities, okay, maybe we have a separate IT department who handles some of this, but in a lot of cases, especially in smaller facilities, it falls back on the broadcast engineer to support a lot of these systems. In addition to the systems that they have to support for the broadcast plant itself, things like automation servers and workstations, maybe audio over IP, or for the television guys now, starting to get into video over IP. Transmitter and site control. It was an excellent presentation earlier on SNMP. I really liked seeing that that demonstration of the SLS remote control as well there. That was kind of cool. And again, of course, telecom, POTS, ISDN, T1, voice over IP, studio phone lines and things like that, and links out to transmitter sites. So let's go back to some basics here. Let's start with just some signal flow troubleshooting. I mean, even though it's a network and anything can really connect to anything else at any given time, depending on how the routing and the rules are all set up, it's still all about signal flow, or I guess in this case, packet flow. So where does it start? Where does it end? What's in between? And again, back to the basics. Let's look at the rules of rock and roll. Is it plugged in? Is it turned on? Is it turned up? Again, always back to the basics. When you start looking at things like this. So it's the same basic process for any system. You follow the path, find out where does the signal stop or where does the issue begin, isolate the problem, and yeah, some signal paths, especially networked paths, are more complex, but the basic process of tracing down signals, or like I said, in this case, packet flow, is pretty much the same. Let's talk about documentation. You want to create or update your documentation as you go. It's really easy to fall into that temptation, especially with networked systems of, oh, it's self-documenting. Well, okay, yes and no, to some extent. I mean, yeah, we're not necessarily keeping wire lists as extensive as we used to. I mean, you still have wire lists for physical connections, obviously, but networking can be kind of self-documenting when you do port names and things like that on switches, but resist the temptation to make that your primary means of documenting things. If your facility is not documented, you're going to have a bad time. Or to quote Napoleon, you're going to have like the worst day ever. So some first steps in troubleshooting. You want to check the obvious, which maybe isn't always so obvious, but again, go back to the beginning. Meter readings, if applicable. Depending on what you're troubleshooting. Look for any indications that are lit that shouldn't, or that are not lit that should be. Power light, again, is it plugged in? Did it lose its source of power? Any indicators lit that should not be? Oh, what's this big red alarm light on this piece of equipment? Okay, is it that piece of equipment, or is it something upstream from it? Look for power, signal, alarm lights, all that fun stuff. So our first steps. Is there an odd smell coming from a piece of equipment? Hopefully you don't have any servers or workstations quite in that sort of condition, but does anything look discolored or scorched? Are there any strange noises, alarms beeping, fans noisy, etc., anything like that? Is there anything that seems abnormally warm? Assume nothing. If there's one lesson I can give you in all of this, it is never assume anything. I mean, even, again, check, double check, triple check. They say the definition of madness is doing the same thing over and over, expecting different results. Well, in the world of IT, sometimes it's not necessarily madness to go back and retrace your steps or to try the same thing again. Okay, so some tools of the trade. First of all, your senses. Again, back to basic troubleshooting step. Use what you've got. Eyes, ears, your sense of touch, your sense of smell, your sense of taste. Okay, maybe not so much unless you're putting your tongue on a 9-volt battery to see if it's got a charge. So one that comes in kind of handy when it comes to the world of IT is a network cabling analyzer. And these come in all sorts of different varieties, some very, very expensive that are actually used by factories to certify cables and connectors and so on, and some that are less expensive. This particular one, I forget what particular model of Fluke it is, but you can find these on the used market for, a few $100s maybe. So you want to be able to identify cable runs. With the more high-end testers, you can actually certify the performance level of those cable runs and terminations. So if it says Cat6, you make sure you've got actual Cat6 performance, because the terminations get a little bit more critical the higher you go in bandwidth. It does basic network diagnostics. Some of these actually have very basic network tools built in, like ping and traceroute and so on, or at least let you establish a link to a network switch to see if the port is live. But unlike a cable tester, these actually do test the quality of the cabling and terminations. Cable testers, and those are out there as well in various forms. They're inexpensive, but they only test DC continuity. They'll tell you if you've got an open or a short, or if you've got pairs reversed. But when you look at things like these types of test instruments from Fluke, they actually give you a lot more information about the connection. And this gets to be really important in modern IP-based facilities. You want as much information as possible when you're trying to troubleshoot these systems. So if you've had the cabling installed as part of a larger project, you may have had some structured cabling installed, and it may have been certified by the cabling installers as part of that project. But again, it never hurts to go back and check this stuff. And yeah, terminations can fail. It's, maybe somebody didn't quite crimp that connector right, and it tested fine initially, but as that port was used a little bit, things wore, or something got worked loose. So here's a little handy tool to keep on hand. A small little managed network switch. And I'd like to thank Wayne Pacina for this little tip. I never really thought about this, but it's kind of handy, actually. A small little 5-port switch like this little Netgear here can perform several different functions. You can use it to create a small network for troubleshooting. You can use it to monitor data on an Ethernet connection to and from a device. So you can use it to create like a port tap and use Wireshark to actually look at the traffic going back and forth. This particular one also supports VLAN, so you can troubleshoot VLANing issues with it. So you can connect to a trunk port on another switch and pick off a particular VLAN from that switch if you need to. So a really handy little tool to have in your toolbox. Another handy little tool to have is a small little travel router. And again, these come in all sorts of different shapes and sizes. This particular one is made by a company called TP-Link. They're fairly inexpensive, well under $100 in this case. It can operate in several different modes. You can either create a Wi-Fi hotspot from wired Ethernet, so it'll act like a small little router, a Wi-Fi router. You can connect devices that are wired only to Wi-Fi networks, and this is also kind of handy. You can do it you can do the reverse, basically, of what a wireless router would do. So say you've got a piece of equipment that only has an Ethernet port on it. Like, for instance, I've got an Agilent Field Fox. or Keysight now, I guess, Keysight FieldFox. Antenna, it's an antenna system analyzer, spectrum analyzer, network analyzer, all that fun stuff. But it doesn't have Wi-Fi built in. It's only got an Ethernet port. And I guess I wouldn't expect a piece of test equipment necessarily to have Wi-Fi. But in order to connect it to a remote control client, like on my laptop or on my tablet, it needs to have Wi-Fi. So I use one of these to actually create a little Wi-Fi hotspot that I can connect to with it. It also allows you to share content from a USB drive via Wi-Fi or Ethernet, again, depending on the model that you get, but a lot of them have this feature built in. And some of them can actually connect to LTE networks as well. So most cellular providers have the little Wi-Fi hotspots that you can buy from them, but they don't always have any kind of, actually most of them don't have any kind of wired Ethernet connectivity. But a lot of these smaller ones, or a lot of these other ones, do have that built in. There's a manufacturer that I've liked to use called Cradlepoint that has a lot of those built in. And there are several other manufacturers that make those LTE routers with wired Ethernet connection as well. So this one should be pretty, pretty obvious to most of us. A laptop. I mean, and maybe it's, it doesn't get used quite as much anymore. I'll get into that in a second here, but things like documentation, configuring your equipment. Again, everything's got an Ethernet port, everything's got an IP address. Most everything's got a web server built into it. Troubleshooting networks, tools like Ping, Traceroute, Nmap, PuTTY, SNMP, which we've talked quite a bit about today, and Wireshark, which I mentioned earlier, which is kind of handy for looking at packet flow between devices and actually more deep analyzing of packets. The onboard Ethernet port is an important feature on these laptops. You can see on this particular little HP, it's got a little flap kind of built into the side there. It's kind of hard to see, but it's right next to the about third or fourth port down from the top. It kind of looks like a squished Ethernet port, but actually toggles open a little bit, and you can shove an Ethernet connector in there, an RJ45 in there. You might also want a USB to serial cable to connect to communicate with legacy equipment. A lot of routers, for instance, like Cisco, they still use serial terminals for configuring, at least initial configuration of a lot of their equipment, and they do make connectors that are Cisco uses a little RJ45 for its serial port, so they actually do make like a little straight USB to RJ45 serial to USB adapter, which is kind of handy. But you do want to make sure that you test it regularly. Software updates like Windows updates and driver updates can break those cables, especially in the case of I know there are a lot of Chinese clone chipsets out there for some of these cables, and it's easy for those to get broken with various software updates. So again, I mentioned earlier, this is kind of rapidly taking the place of laptops out in the field. The tablet. I actually, on my iPad, it has LTE built in, so I can actually use my iPad to replace my laptop out in the field. When I don't want to take my laptop with me, I'm able to connect back to a virtual desktop running Windows and get inside of our network and get to any of the equipment that I need to talk to right from my tablet. But again, it has the same tools on there that you can use for documentation. There are versions of Word that you can run on here and other Office tools. If it's LTE equipped, you can use it as a Wi-Fi hotspot. You can use it to get into the browsers of the equipment on site or the web interfaces for equipment on site for remote control. Or if your remote control system happens to support some kind of browser interface, you can do that, or an app, you can do that. And speaking of apps, there are a number of various helpful apps and network troubleshooting tools that you can use, again, depending on the platform. And I show an iPad here, but it really doesn't matter if it's an iPad or if it's an Android device. They're both very flexible when it comes to this stuff. Some would say that the Android devices may be a little bit more flexible because they kind of run, they can be jailbroken or hacked or things like that to add a little functionality. Apple's a little bit harder to do that on. But there are a number of helpful tools already built in or that you can download as apps from the various app stores. And it allows things like remote access to other systems. You can get things like TeamViewer as an app to run on here, and most of the other major remote control packages that you can think of are desktop remote control packages. One of the big advantages is that it's a lot smaller than a laptop, so it's easier to carry it with you when you're going to a remote site where you're really limited on what you can carry with you. Rather than carry a monstrous laptop, if you're able to just carry something like this and maybe a keyboard to go with it or a Bluetooth mouse, then off you go. Some of them are able to use a wired Ethernet connection. Some of them aren't. Again, it depends on the platform. Android more likely to be able to use something like that. I know on the iOS platform, they do have some support for external USB devices as well, but I don't believe you can use an external Ethernet adapter on iOS. But again, that's where that little travel router comes in handy, as I mentioned. Let's talk a little bit about various cable terminations here. And the one that we're going to see most commonly, of course, is the RJ45. Nice thing is it actually can be used for more than just Ethernet. You can use that in place of a number of traditionally copper-based interconnects, like audio, for instance, analog or AES. You can run that over RJ45 connectors all day long. In fact, there's a standard called Studio Hub that does exactly that. It's a compact form factor, which gives a really high connection density. As I said, you can use it for many types of signals. It's typically used for Ethernet, but not always. Again, I mentioned the Studio Hub system, a company now called Angry Audio that actually bought all of the Studio Hub product line and is producing those adapters and things now, which isn't Ethernet or IP. It physically and electrically converts to or from other types of connectors to RJ45, but does not change the format of the signal. It does allow use of a common cabling infrastructure. So if you've got Cat5 or Cat6 cable run all over your facility already, this might make some sense. Standard patch panels allow for easy routing and infrastructure changes. It can be installed by IT and cabling personnel who may not be familiar with broadcast standards and requirements. You wouldn't expect a structured cabling guy to come in and start soldering XLR or TRS connectors, for instance. But you do want to make sure you're using the right connectors with the right cable. There are cables for stranded, there are cables for solid, there are cables for Cat5, there are cables for Cat6. Just make sure you're using the right connectors and the right termination tool for those connectors with the right cable. So let's talk a little bit about some of the signal types we might see in a facility, not necessarily related to IP, but we'll get to that. So we might see DC, we might see some serial control and metadata, and we might see some custom and proprietary schemes. The other signal type that, and this one does relate to IP, is audio over IP. Audio over IP can replace most analog and digital audio connections within a plant, but it only requires them at devices that don't natively speak AOIP. So in other words, there are devices where you can literally just plug in an Ethernet connection and it's already speaking audio. This console that I have behind me is an example of that. I only have a handful of devices plugged in locally, but once I get it connected to the rest of the AOIP plant here in the facility, I'll have access to anything that's available on that AOIP network without running any extra cabling. There are various schemes and manufacturers. The first one, and one of the first that came out was from a company it was from Axia. It's called Livewire. Wheatstone developed their own called WheatNet. And then there was another company called Audinate that developed a standard called Dante. So these are three of the most common kind of proprietary standards that you might encounter out there in the industry. But then there came a standard called AES67, which allows all of these to interoperate, at least as far as passing audio between the devices. So now we're going to talk a little bit about voice over IP. So VoIP can replace POTS lines, T1, T3, and other legacy voice circuits. It uses industry standards such as SIP, which stands for Session Initiation Protocol. Your studio phone systems now can be run using voice over IP. Kirk mentioned the VX in his earlier presentation, so here's one example of that. It can integrate with audio over IP systems, and your office VoIP phone systems. Again, I won't, Kirk touched on that a little bit earlier. And offers considerable flexibility compared to legacy telecom circuits. So now let's talk a little bit about some encoded audio. It is a form of AOIP, but since this is actually bit-reduced audio, it's not quite what we would normally think of as our in-studio AOIP. But these audio codecs, and I know, Mark, you probably recognize these, the Bridgets from Thailand, they can replace ISDN. They use a mix of standards and proprietary encoding, and they often incorporate some VoIP technologies such as SIP. They're designed for passing encoded audio over the public internet or across private links with limited bandwidth. So you generally wouldn't use this type of encoded audio within your studio facility itself. It's more for external site-to-site links like an STL or a remote site and things like that, remote broadcast and so on. So we can also pass control and metadata over IP, as I was mentioning those control signals earlier. That can replace these GPIO and serial connections. And again, SNMP is a huge piece of this as far as passing control data and information over an IP network. It can be either independent of audio or embedded with it in some cases. So standards like SNMP would run completely independent of any kind of audio related data. But things like Livewire and WheatNet and Dante, they all have their own kind of embedded control information as well for things like microphone preamp gains and GPIO, but that is specific to each of those manufacturers. So they each have their own various proprietary schemes. So there are standards for carrying this control data across a network, but it's still very much kind of a work in progress. So some other IP traffic that we might have running around our facility: streaming audio, internet access for the studios and for the offices, various office and administrative functions, and nearly anything else. Let's see here. So the type of equipment that we might see for AOIP, it might be called a node or a blade or something else. It's basically just an end device that converts uncompressed audio and control to and from an audio over IP domain on a local area network. So think of it as an analog to digital, digital to analog, digital to digital type of converter that just has Ethernet as one of the sides of that conversion. So there are other AOIP capable devices as well, like satellite receivers, audio codecs, automation systems, PCs, digital audio workstations. These can all have virtual sound cards in them, so you don't have to actually physically connect a bunch of discrete audio connections to them. As I mentioned earlier, your voice over IP broadcast phone system, your IP codecs, again, like the nodes and blades, but with the specific purpose of handling bit-reduced audio across lower bandwidth connections. So audio consoles, again, physical control surface for mixing your audio, again, all in the IP domain. It's like a giant keyboard and mouse, basically, for your audio. It's not actually handling any audio. It's just sending commands to devices elsewhere on the network that are mixing and handling that audio. And again, all in the IP domain. The failure of this doesn't take you off the air, but you'll probably lose control from that particular surface. So if I spilled coffee on this console here next to me, well, A, I would have somebody probably pretty mad at me, and B, well, I'd still be playing audio, but I wouldn't be able to do anything. You can implement a console either in software or in hardware. I know Mark's got some software control panels built up for routing within his facility, and do the same thing around here. And it's actually kind of handy to be able to do that without necessarily needing an actual console or routing surface or router control panel next to you. All of the heavy lifting happens in a mix engine or a blade or some other device that's on the network that's actually handling all of that mixing. Again, just connected via usually a single gigabit Ethernet connection, and handles all the mixing in software internally based on the commands being sent to it. So this is just any device on the network that routes and mixes multiple sources. You control it via the physical console surface or virtual software console or any other means, even physical GPIO if you'd like. There's usually one of these dedicated per audio console, but often it's a shared resource within a facility, and in some cases it's even built into the console itself. So let's talk a little bit about the network gear behind all of this. Network switches, most of you should be pretty familiar with. You can get the smaller edge switches. Usually these would be mounted like in a studio or a wiring closet, and these might be like anything from little 8-port switches up to 16 or 24-port switches. And then the larger core switches. Now these might be like larger 48-port, or in some really large installations, a large blade-based switch in your main tech area. Again, it could be shared, or it could be dedicated to a single purpose. A lot of people do like to dedicate switches to specific purposes. In other words, like you've got a switch for your office network, you've got a switch for your AOIP network, you've got a switch maybe just for your VoIP, although often that's integrated with your office network as well. Again, it really just depends on how the infrastructure is set up. Routers, not to be confused with audio routers. These basically just link different networks together, and sometimes that can actually be a function that's built into a layer 3 switch as well. They can have some firewall functionality built into them as well. So how do we troubleshoot IP networks? It's a little trickier since Ethernet and IP paths can carry multiple types of data or take multiple routes. But like I said, the same troubleshooting concepts that have always applied in our industry still apply, but just in a different way. This is where things get a little bit interesting. There's this thing called the OSI model that kind of describes different layers of networking topology. So if we take a look here, it's like a layer cake. There are 7 different layers here. So the physical layer, the data link layer, network layer, transport session, presentation, and application layer. Most of what we're going to be dealing with would be down in the lower few layers. For instance, the physical layer, that would be your Ethernet layer, or your actual physical connection. The data link layer, that would be your Ethernet level layer, like the MAC addresses of the card. Network layer, that would be like your IP addresses. Transport layer would be what you're transporting over IP, like TCP IP or UDP IP. And then session, presentation, and application, that mostly gets to the user side of things rather than the networking side of things. And a lot of times, a lot of those layers might be even lumped together in some cases. So the first thing we want to do is troubleshoot those physical links, your layer 1 links. Look for link inactivity LEDs on the Ethernet ports. Swap Ethernet cables and or patch ports. Check any interconnecting wiring. Are the pairs in the correct order and polarity? Here's some other things that can trip you up. 568A versus 568B. These are 2 different wiring standards for the color codes in a CAT cable or an RJ45 connector. Electrically, they're identical, but since the coloring is different, it can really trip you up. So most facilities now are going to be 568B, where that white-orange pair is the first one, whereas with 568A, the white-orange pair, or the green-white pair was the first one. So the positions of the green pair and the orange pairs are flipped between A and B. And if you actually, if you do that accidentally, it ends up as a crossover cable, which isn't necessarily the worst thing in the world because a lot of equipment will detect that and correct for it automatically. But again, you want to be consistent. It can cause some issues if you're not consistent within your plant. So the next thing we would check for would be speed and duplex issues. Again, this is a layer 2 thing. Sometimes they can be set incorrectly in your network card. It should almost always be set to auto on both ends, or in rare cases forced to the same setting on both ends. And this is something that actually changed once we went to gigabit Ethernet, which generally you are going to want to leave forced to auto on both ends. So troubleshoot the equipment next. Do some ports work and others don't? Is it dead entirely? Is it passing some traffic but not all for specific systems and devices? If you've got a managed switch, check for VLAN assignment issues. This is a pretty common one, actually, if you do have a common set of network infrastructure for various things. Maybe the port's not assigned to the right VLAN. So if ports are assigned to specific VLANs according to their purpose, if you try to use a different VLAN and wonder, oh, why can't I get to that system? Oh, okay, it's on a different VLAN. So the next layer up would be troubleshooting at layer 3, the IP layer. The ping tool basically. It allows you to just see if an IP address is alive, how long it takes to get to and from that IP, the round trip. Can you reach that device from a system on the same subnet or on a network routable to that subnet? Can you reach any other devices on that subnet on the same switch? And then try connecting a laptop directly to the device and manually configuring the NIC on the same subnet. Can you talk to it that way? And if not, then there's probably a problem with that particular device. So again, just continue following the path through the system through any additional switches and routers. So some other tools that are available, traceroute. This really can come in handy if your network is a little bit more complex, involves multiple subnets, or if you're trying to trace to some external resource. It'll show you where the traffic stops, basically, and that's generally where you're going to want to start. I mentioned Wireshark earlier, so this actually will get you down to the layer 2 level as well. So you can actually see the packets coming between devices. So you want to see if there's any detectable traffic coming from this device at all. Anything being directed at that piece of equipment or any response from it. Might need to, so there's in these managed switches you could set ports to monitor modes. They can actually pass all of the traffic coming across that particular VLAN rather than just traffic destined for that particular port. That's also where that little 5-port switch I showed earlier might come in handy. So do we have outside internet connectivity issues? Check the modem or router. Does it have the normal light indications? Connect a system directly to the router. I mean, if that fails, connect a system directly to the modem. Check with your ISP to see if they have some issues. And when all else fails, try a reboot or a power cycle. And I'll give you one caveat there. When it comes to managed switches, especially Cisco, for instance, if there's a config that's running on a switch that has not been saved, you'll likely lose that config when that switch is rebooted. So you want to make sure that that's taken care of before you actually try rebooting a piece of equipment or a switch or a router, for instance. I mean, like I said, the risk is that it may fail in the process or won't come back to a functional state. So all that said, now let's talk a little bit about IT security. So what type of security do we have? First of all, the physical security, and this would be your facility security and your access controls, things like your cards, your keys, things like that. Securing hardware, locking your equipment racks and your enclosures, or putting equipment into locked enclosures. Electronic security, you want to check passwords, make sure that passwords are strong. Firewalls, you definitely want to have secure firewalls in place. And 2FA, two-factor authentication. We'll talk about that in just a little bit. And then, of course, there's the human factor. You really are, and your users are, the last line of defense against compromise of your systems. And a lot of that really does come down to staff training. Social engineering is probably one of the biggest risks to any of your systems. Again, we'll get into that in just a little bit. So as far as connecting systems to the outside world, it has to be done with caution. It's getting more difficult to create these little islands that don't speak to the outside world anymore. I mean, there seems to be always some kind of need for outside connectivity. Regardless of the system. Maybe the vendor needs remote access for support. Maybe it needs an update that can't be practically carried over via like SneakerNet or something like that with a USB drive. So it's outside connectivity to a lot of these systems is almost becoming a necessity. But as we know, the internet is not a friendly place. There are constantly bots just out there probing and scanning for things that look interesting. Your firewall is your first line of defense against that. If your devices can't be seen, they're less likely to be hacked. It's called Shodan.io, and I don't know how many of you are familiar with that, but basically it is a search engine for IoT devices, anything basically that's exposed to the public internet. So if you go into Shodan and type in, for instance, for FM transmitters or AM transmitters, for instance, I'll pick Nautel, since I know that they're very well aware of this and try to educate their users about this as well. So if you type in Nautel, you'll see something like maybe 15 results come back. And that's actually not bad. I mean, worldwide, It was a lot higher before they started actually reaching out to users and saying, hey, secure your stuff. But if your audio codec, for instance, is out there on the public internet and somebody gets into it, well, they can take over your station, and if they change the password, there's nothing you can do until you can get to the transmitter site and physically disconnect it. So some best practices here. Keep your systems up to date. And again, I know I hear people screaming from here, but I've got this Windows XP box that does exactly what I want it to. And no, you need to find another solution. It's not a matter of if, it's a matter of when. Something will happen to that box and it will cause a problem. Antivirus software, same thing. You'll want to find, I mean, Microsoft has some pretty good solutions to this actually now built into their systems, but there are a number of others out there that are fairly unobtrusive and can be managed on on a network-wide level. You want to use fault-tolerant hardware wherever possible, redundant hard drives, things like RAID arrays, things that offer you some redundancy. Keep backups, keep them up to date. Things like offline and off-site backups get critical, especially in the case of something like ransomware, where you've got something that will literally just crawl across your network and start encrypting all of your files. Even if your backups are supposedly current, if you can get to that backup server, so can that ransomware. So there's a set of standards out there that was developed by the payment card industry. And it's very, very stringent in terms of what your internal network security precautions should look like. I'm not saying everybody needs to implement every single piece of PCI, but I mean you do probably handle some sensitive data at your stations. So if you haven't already heard about this, I'm sure at some point you will be. Somebody in some auditor is going to come along and say, "Hey, we need to be dealing with PCI compliance," and it is pretty rigorous. So. Security through obscurity is a trap that a lot of people fall into, and it's almost as bad as no security at all. Well, I've got this system port forwarded on some random non-standard port. Well, okay, that's great, but if there's a scanner out there, it's still going to try and randomly poke at you, and eventually it will find it. The other thing that I've seen a lot of is systems that are dual-homed, which is connected to multiple networks with dual NICs. At one point in time, I was a big fan of that, and I thought, oh, this is great. I can connect the system to this, and it's still an island, and I can connect it to this other network. Well, guess what? The moment you connect it to that other network, it's no longer an island. It's now on both of those networks, and both of them can be compromised through either of them. So better way to handle that is actually proper routing internally through firewall rules and access control lists and things like that. So yeah, like I said, access control lists, ACLs, and other restrictions at the router and the switch level really can come in, really will help you here. You want two-factor authentication, 2FA, for as many sites and logins as possible. And two-factor authentication consists of something you know, like a password, and something you have, like a physical token or your cell phone, something like that. And between those two, it really makes it a lot more difficult for systems to be compromised, because the attacker has to be able to have access to both of those things. Use strong passwords. That doesn't necessarily mean you have to have some random jumble of letters and numbers and special characters. In fact, that actually can be less secure in some cases. You might want to consider passphrases. This is actually a really handy tool. You come up with some phrase that's easy to remember and use the first letter of each of those phrases. Let's see here. And if you want, maybe throw some punctuation at the end or something like that. But that's actually a really, really difficult password to crack, but it's easy for you to remember. Use VPN for remote access to facilities. I see port forwarding so often, but I really, really caution against port forwarding, again, because it's not a matter of if, it's a matter of when something will find that and something will get through. Using VPN makes it a lot more difficult, if not, well, I hate to say impossible, but it's very, very, very difficult for someone to actually compromise a well-designed VPN infrastructure. And you can actually set up either client to remote site VPN, so your laptop connects to that remote site directly over a VPN, or site to site VPN, which links your two networks together. Again, back to one of the biggest topics that I talked about in terms of threats to your infrastructure, social engineering. And this can come in the form of emails, phone calls or voicemail, instant messages, SMS. Even the best security in the world can be defeated by a well-meaning user. It just takes one click on a link in an email, and you're done for. There are some tools that you can use to actually scan those links in those emails and make sure that they don't reach the user in the first place. But even then, the attackers keep getting clever and clever, more and more clever. It's a constant game of cat and mouse. And users, there are some very convincing ones out there. So even the best, even the best trained user can sometimes fall for these. But the key is training of your users. One site that I can suggest for things like that is called knowbefore.com. They have a lot of great resources in terms of training for users against things like phishing and social engineering. So some of the exploits that you might see, ransomware. We've heard a lot of stories about this recently, where companies' entire file, all of the files on their infrastructure get encrypted because it just goes in and spreads like wildfire. Viruses and malware. This has been a threat for many, many years, and continues to be a threat. Remote access tools and keyloggers. Again, something that's not new, but it's something that still remains a threat. But one of the bigger ones is also unpatched systems and OSs. Again, don't fall into the trap of, oh, I've got this Windows, I've got this Windows XP box, or I've got this Windows 7 box. It's working great. Why should I change it? Well, eventually there will be, some exploit, and there will be some, something will compromise it eventually. It's just a matter of time. So one last topic that I want to talk about really quick, and this can help with a lot of this as well, is virtualization. You can actually use virtualization to replace hardware servers in a facility. And these can be either on-site, or these can be hosted elsewhere, like in Amazon Web Services, AWS, things like that. You can use it to replace a lot of hardware servers, but one of the cool things is it also allows for a sandbox environment where you can test ideas and systems. So that's it. That's what I've got. Any questions? Let's see. I see something in the chat here. I can get to the chat.
Got a question for you, Shane.
Yeah, go ahead.
So you mentioned dual home systems.
Mm-hmm.
So a major audio over IP manufacturer recommends that for their computer controlled, Pathfinder. It's Pathfinder. Suggestions for workaround of those kind of things, where you got your isolated AOIP island.
Right.
Life is good, but you've and you gotta have something.
I make blanket statement like that, but there are ways. There are always things that you have to look at and considerations. Sometimes it's not possible to avoid it. I have situations here like that exactly. Pathfinder is one case where it talks to your AOIP network and it talks to your business network, and it has to, because you need that access on those business network machines. But again, that's where things like the routing rules in your system come into play. If you have something like inter-VLAN routing set up, for instance, where you can route from one, you've got your AOIP network on one VLAN, you've got your business network on another VLAN, but yet they can still see each other through the gateways that they're pointed to in your network. That's definitely one solution. But I always kind of looked at dual home systems as, oh boy, now I've got double the targets and double the exposure. So, if an attacker gets into a PC that's got two NICs in it, oh boy, look, now I can compromise two networks. So that's,
Well, and on that same note, and I was talking to somebody with White Orbit yesterday, in fact, that one of the things they really push is to have a PC set up as an intermediary between say your office network to your automation network. So that traffic, if, for example, wasn't connected directly to the automation through the same network, it was going to go through this computer, and whatever files were uploaded from traffic were going to be scanned and thoroughly checked into this computer before it was taken into the central server, for example.
Yeah, and I know that's certainly that. Yeah, I know. For instance, Jeff Welton. There's a station that he does some, that he helps out from time to time, and he mentions a case where they have a computer that's only purpose is to scan external media, and certainly that's one possible solution. You have a machine that basically makes sure that anything that does come into your other network is clean before it actually gets inserted. But again, the onus is on the user there. So,
well, what's your thoughts about whitelisting?
I think it's a great idea. It's a great idea.
Jeff and I are big users of Ubiquity edge routers for our sites.
Yep.
And we figured out that, hey, we could build whitelists and literally minimize the access to those sites. And I had one site in particular that I think was getting scanned and jammed by bots. And by remote control, I would have to reboot it every day, power cycle it every day to be able to get into it.
Yep.
And after I built a whitelist, it all stopped.
Yep, exactly. And back to, like I said, you can't hack what you can't see, or at least it makes it a lot more difficult to hack what you can't see. Anybody else? Well, guys, I've really enjoyed this. Thank you so much for inviting me. I hope it was helpful and informational, and yeah.